Hi, so I want you all to watch this complete video for the solution of this CAT 23, the third slot question. And in this, we will see a quick shortcut to answer this particular question. So stay tuned and be with me till the end. But first, please pause the video and do try solving it on your own. Alright, so the question reads, a rectangle with the largest possible area is drawn inside a semicircle of radius 2 centimeters. Then the ratio of the lengths of the largest to the smallest side of this rectangle is. Okay, beautiful question. It's a very easy question if you know the basics of geometry. We have a semicircle and we have a rectangle that is drawn inside this semicircle. The question says that the radius of this semicircle is 2. So this is basically 2 centimeters. Now let's call this angle here as theta, right? You will notice that this entire part is the length of the rectangle and this entire part is the breadth of the rectangle. Needless to say, by symmetry of the figure, this part is going to be half the length or L by 2 and the angle between the length and breadth is 90 degrees. Now I want you all to notice something in this right angle triangle. Okay, I can apply some basic trigonometry and say sine theta will be equal to b by 2 and cos theta is equal to L by 2 divided by 2. From here we will get b as 2 sine theta and L as 4 cos theta. So we have found the length and the breadth of the rectangle in terms of the angle theta, right? Now the area of the rectangle is always length into breadth. So for this rectangle, the area is 2 sine theta multiplied by 4 cos theta. So retaining the 2 here, 2 sine theta multiplied by 4 cos theta. I'll club together the 2 sine and the cos term. So I'll get 2 sine theta cos theta multiplied by 4. Now, if you notice carefully guys, we have a trigonometric formula for this part. 2 sine theta cos theta is nothing but sine 2 theta, right? So the area of the rectangle is sine 2 theta into 4. The question says this should be maximum. And 4 being constant, area is maximum when sine 2 theta is maximum. The value of sine theta is always maximum equal to 1. So sine 2 theta should be equal to 1. And for sine 2 theta to be equal to 1, 2 theta should be equal to 90 degrees because we know sine 90 is 1. Dividing by 2 on both sides, we get theta as 45 degrees, right? So that's the whole point. We have to figure out the value of theta as 45 degrees here. And now things become very, very simple. The value of breadth we know is 2 sine theta. So we can rewrite the breadth as 2 into sine 45. Sine 45 is what? 1 by root 2. So breadth of the rectangle is simply equal to root 2, right? Same way length is 4 cos theta. So length will be equal to 4 into cos 45 is again 1 by root 2. So 4 upon root 2. We can write 4 as 2 into 2. And we have root 2 below. Root 2 and 1 root 2 gets cancelled. The length of the rectangle is simply 2 root 2. So that's it. We are almost there. We need the ratio of the length of the largest side to the smallest side. Meaning we need the ratio of the length to the breadth. So what we are looking forward to is the ratio of 2 root 2 is to root 2. Root 2 and root 2 will get cancelled out. My answer is option A, 2 is to 1. Right? Very simple question. If you proceed by trigonometry also, this is how we'll be able to do it. Now there is a much better way of solving this. Let's see how. Hi. Don't forget to check out my course for the quant section of the CAT exam where I've explained all concepts, tips and tricks, shortcuts and past year questions in great detail. Okay, now the question says we have a semicircle and inside that we are drawing a rectangle of the largest possible side. Right? Now I want you to create the water image of this particular figure like this. Okay. So now we notice that we have a rectangle drawn inside a circle and now this rectangle should have the largest possible side. When will this rectangle have the largest possible side? When this rectangle is actually equal to a square or when this rectangle is a square. Right? For this square, let us suppose the side is equal to x. So this part is half the side. It will be equal to x by 2. So now you can very clearly see what I want you to observe. The length of the larger side of the rectangle is x and the smaller side is x by 2. We simply require the ratio multiplying by 2 on both sides and cancelling out x, the ratio required is 2 is to 1. Very simply, we get our A option. So this is a very quick shortcut to answer the question. If you can just create the mirror image of this diagram, notice that the rectangle inside the semicircle is a square inside the circle. The answer is 2:1.